everyone, welcome to the live stream. This is episode 133, and once again, Boris will be going over how to set up ESP32 programming with PlatformIO on Visual Studio Code, our favorite editor. One of our team members, Antonio, figured out how to do it. We're super excited about it, and one of our contributors, Alexis, helped to document it into a Hackster guide, which we'll post later today. And Boris will go over it, and he also put it in the docs. So that's how we're going to go over today. Okay, Boris, take it away.
All right, great. Yeah, so if you could switch the camera over, please, Samarine.
Yeah, if you give me the mouse.
Oh, yeah. Oops.
1 second. There we go. Cool.
All right, great. So in our docs, if you go here and you go to Matrix Voice and ESP32, you'll find the brand new PlatformIO guide. And so I'll just be walking you through that today. So I already installed this on my Pi. It takes a little bit to do the update and upgrade, but if this is a fresh Pi and you didn't already install Matrix Creator in it, please do that. So I'll just be walking you through that right now. I'll just copy and paste all of this bash code to get our repository key, update the repository, and then install the init package. So doing that upgrade. Should be pretty fast now since I already did it a few minutes earlier before the stream.
Nice.
Yeah.
So update and upgrade is...
And then here I'll install the init package.
Nice.
Which, yeah, it's already installed. After the init package, you should reboot your Raspberry Pi because this installs a service that'll flash to FPGA on first boot. And before using it initially, when you get your ESP32 Matrix voice, you'll need to make sure that the FPGA gets flashed. So I'll do that reboot right now.
Nice.
And I'll just wait for the Pi to come back online before SSHing back into it.
Cool. I like how you're saying every step very clearly. So yeah, you have to give it like 15 seconds for the Pi to reboot.
Takes a bit.
Yeah. But those steps are as easy as copy paste. We just like did them before, so we don't spend any time doing them again. All
right, so I'm back in my Pi.
Cool.
Nothing's there right now. So I'll run this command, sudo voice ESP32 enable. What this does is that it prepares the ESP32 for flashing.
Right.
Then I'll go ahead and I'm going to erase the flash memory of the ESP32. You should do this before running the install.sh script, which I'll show you in a moment.
Oh, you just clicked save instead of paste.
Oops. Alright.
So this command just resets the memory. So if you had anything on it, it erases it. Pretty cool. And then after that...
Alright, so the Pi setup's done, and we're going to move on to the PC setup. We already have Git on this computer installed, but if you don't have it installed, please follow this link and just download the one for your respective platform and install it.
Cool.
We also already have VS Code installed, but if you don't have that installed, then just, yeah, here's the link for that.
You should install it. It's a good code editor.
It's a very good code editor, very extensible. And then for PlatformIO, we'll go to that and we'll install that, which we already have installed, but just to show you. So just copy this. Inside of Visual Studio Code, I'll go into this little thing. It looks like a block with a few blocks outside of it, and I'll just paste that right in there, and it should show up. Yeah. So then here, I would just, for you, you should see an install button. So I'd click that. And then once it's installed, it'll ask to relaunch VS Code. Just do that. And then you'll also need to add PlatformIO to your path. So PlatformIO creates a command line tool called PIO, which you can add to your path so you can call it from anywhere in terminal. So I'll be doing that right now.
Nice. So PIO is basically PlatformIO's
yeah,
command
the PlatformIO, yeah, the CLI.
Right.
So I'm on a Mac, which is Unix-like. So I'm just going to go here, and I'm going to take this and put it inside of my profile.
And that usually means that it's accessible from any terminal?
Yep, any bash terminal specifically.
Bash terminal.
If you're using ZSH, then the instructions for that will be a little bit down. Oh, here. for ZSH, just instead of profile, edit Z profile.
Right. It's nice that they have instructions for all of that.
Yeah, so I'll just show you this.
Profile.
Yeah, so I already put it in here a little bit earlier, but if it's not here in your file, just add that, and then if you're using Nano, it's Control X to exit it, and it'll ask you to save if you added something to it.
Yeah, and then just press Y to save it.
And if you're on Windows, you won't follow this. You'll instead actually just go to Windows, and you'll follow the instructions here. So after this has been completed, we're going to go ahead and we're going to clone the PlatformIO repository. This is like a good starter repository for your personal projects or whatever you may be working on at the moment. So I'm going to, I'm actually going to clone this onto my desktop, not on my Pi. So I'm going to go into a folder that I made for the live stream.
Cool.
All right, and I'll clone it into here. Great. I'm going to then open this up inside of VS Code. So, yeah, I already have it in here, but if you don't, just open that up. And then inside of here, you'll see a platformio.ini file. This is pretty important. You're going to have to edit this to enable the OTA functionality, so you can update it without the Pi connected to it. So I'll just put my SSID in here.
Oh, okay. Dummy SSID.
And then I'll put it here.
Right. Whatever your SSID and password is. This is totally our SSID and
right,
password.
Yes.
Yeah.
So our actual SSID and password is in this other file, which we just don't want to show this on stream. So this is what you'd have to do, though, in like your circumstance. Just put in your SSID, your password, and make sure that you have these two quotation marks here. This is really important.
True. It's annoying when little things like that make your code not work. Like, oh, I forgot a quotation mark. Also,
if you're using Windows, there's one more step. You're going to have to go down here, up here, where it says upload port. And instead of mvesp.local, you'll have to put the actual IP of your Pi. This is only if you're on Windows. So the IP of my Pi is 192.168.1.217. So I'll just put that in like that without any quotation marks. Great. So that's all the edits you have to make to your PlatformIO INI file, and I'll just show you how to do an initial build and then a deploy onto the device. So once again, I'll just copy this file over because this one contains the actual SSID that I'll be using. I'll just change this.
Yeah, that makes sense.
I'll put that in here.
Cool. Move. Yeah. Nice.
Okay.
All right.
So we're on step 4 now. We're going to build it, we're going to deploy it, and then I'll show you how to do OTAs after the initial deployment.
Right, and OTA is over the air, so you just could like program it over Wi-Fi.
Yep.
Cool.
So I'm going to go into here, to open, and I'm going to open the project. My project's located inside that live stream folder, so I'll go into there, and I'll just click open. There we go. And for some reason the buttons here are not showing up for me. Oh, there they go. Yeah.
Cool.
So I'll click this, which will just build it. Alternatively, if you prefer using like terminal tools to GUIs, you can always run the PIO run command instead of that little check mark. So I'll also just show that.
Cool.
I'll just wait for this one to finish first.
Right. So it does the same exact thing, you're just doing it to the terminal, the command line?
And the first time it'll take a little longer since it's downloading all of the necessary frameworks and tool chains for your ESP32.
Right. And how it knows to download all of these because of...
So they're actually inside of that inside of the sample file. Inside of libdeps, you'll see that we have the ESP32 HAL as a dependency, and then we have the OTA as a dependency. So to add like libraries, you just put your library right into here as a GitHub link. It'll download the library, it'll find all the files, and it'll put it into the correct place. So then you can just include them and it'll work.
That's so amazing.
Yeah, the first time I tried this, I was amazed at how easy it was.
Yeah.
It also knows to download the ESP32 toolchain because the board here listed is ESP32 dev.
Right.
And the platform's Expressive32. So it'll get all that for you. You don't have to do that manually anymore.
That's awesome.
Yeah. So I'll just show you the PIO run. So just a terminal alternative to pressing the checkmark button. Ah, yes. Okay. I'm not actually in the project folder.
Oh, okay.
So let's try that again. Okay. There it
PIO
goes.
run.
Yeah,
Nice.
that's better. And so it'll show you all the dependencies you currently have, and then at the very end it'll even tell you how much of the memory your program executable is using. So you'll know how much you have left for like additional libraries or extension. Yeah, so it's currently using that much.
Oh, nice.
So the first time you end up installing it onto the Pi, you'll need to use this install.sh script. Then afterwards you'll be able to use the actual OTA. Because you first have to flash the OTA like bootloader and the OTA parameters onto your ESP32. So we'll do that right now. I'll go into that OTA folder. So I'll just cd OTA. And then inside of here, I'm going to run install.sh with the IP of my Pi.
Nice.
So what this file does is that it'll transfer the compiled binary over to the Pi and it'll flash it. Yep, so I'll just put in the password here. Oh, oops.
Did you put in not Raspberry?
Yeah, I'm typing Raspberry, but there it goes. Okay.
Okay.
Great. So the initial deployment will take a long time. This is going directly over the UART pins on the Pi, and it's limited to a fairly low baud rate. But after the initial install, using this command to do an actual OTA update should be around 4 times faster than the initial one. So don't worry that this takes a really long time. That's normal.
Yeah. We were just talking about that too. I also didn't notice that at first, that like it's so much quicker over Wi-Fi than it is over the Pi because we're limiting with the baud rate.
It's a huge difference. I've been working on like a personal project, and just being able to use OTA makes developing so much faster because, you know, to deploy it takes like 40 seconds with an OTA versus 2 to 3 minutes with UART.
Yeah.
So that's a big difference.
Though I will say I did try with a higher baud rate for UART, and it doesn't work if you want to do debugging with serial. Like if you want to be able to read the serial data, you can't use a higher baud rate. You need the 115200 at least to be able to read it. So you shouldn't change that if you were wondering.
Yeah. I'll show you later how to read from the serial port.
Yeah, it's really handy because for debugging especially, like knowing what is where it's actually like crashing, if it does, things like that, super helpful.
So it's almost done. It's taking a little.
Yeah.
But that's normal.
Should we hold this up so people can see?
So once it's done, it should
pretty quickly start doing the program.
Yep, there it goes.
Yay.
So that's the demo that's running right now. And so if you actually disconnect this from the Pi, it will continue running. Well, once you provide power to it.
Yeah.
We strongly advise against disconnecting it from the Pi when the Pi is powered, even though that seems like
tempting.
Yeah.
Yeah, don't do it. I know it can be annoying to like feel like, oh, I need to unplug, take it off, replug, but it's the safest. You don't want to break your voice or the Pi.
And so now I'll show you how to do the OTA. So I'll just grab this. And before I do the OTA, I'll actually just make a small modification to the code. This modification will just send stuff to the serial port, just so I can show you how to read that later.
That's a good idea.
So I'm not sure which one of these is the right folder. But these should point to the same one. I think I just opened it twice in VS Code, which is no big deal, really.
Yeah,
I'll just go into here, and I'll go to the bottom. And I'm just going to go ahead and do serial.
Okay, so you're printing like
I'm
whatever.
I'm gonna
something.
print just like a string.
Yeah, perfect.
Repeatedly in a loop.
And you've already
just so I can read that later.
You've already set it up in the code and set up like the serial.begin. And
right,
all that.
right.
Okay,
that's
cool.
inside the example. So that'll set the example will set up that. It'll set up the microphones and it'll also set up the over the air.
Perfect. Yeah.
And then this is the code for that little animation that you see.
Okay, so if people want to edit this, they have to go to src and then edit main.cpp.
Yes,
okay.
Although it doesn't have to be called main.cpp. You can call it anything you want. It can be like everloop.cpp or like audiostreamer.cpp, and you can also have multiple files inside the source, and then just link them together with includes, like you would do in any other C++ project.
Cool.
PlatformIO also has like test cases built in, although we're not going to be going into that. That's more of an advanced topic.
Cool. Good to know that it's there.
Yeah. So I edited this, and I'm just going to save that, and I'm going to run the OTA. And you should see the OTA should be way faster.
Okay, yeah, I'll hold it up, because we should be able to see...
Yeah, it'll pause once the OTA starts.
Okay.
Oh, I did that again.
Oh,
I was inside.
Not in the folder?
Yeah, inside. You have to be inside the root folder, instead inside ESP32 PlatformIO, not inside the OTA.
Okay, so you have to be in ESP32 PlatformIO, so CD out of OTA folder. Okay.
So it'll recompile that, and it will just go ahead and deploy it. And once it starts deploying, so here it's still compiling.
So which file do you say to compile main.cpp in? Like, which file says, oh, main.cpp needs to be compiled?
PlatformIO handles that. You can call it whatever you want. You can call it Everloop. You can call it anything you want.
It'll just automatically.
Yeah, it'll just do it.
Oh, perfect. Cool.
So you should see this is going like way faster.
Nice. Yeah, that is way faster. Like, I'm pretty sure you're right. If we timed it, it would be like, I don't know what you said, 4 to 5 times faster or something like that.
And then it should start again. Okay. And now this is the modified version of the code, which is sending serial output. So this concludes the portion of the guide that just has like OTA setup. Now we'll show you how to read the serial port. The UART. So on your Pi, you'll need a program called Minicom. This is used to communicate with the serial port.
So that's not the Pi.
Okay. That's not the Pi. Cool. Thank you. Yeah,
just
so make sure you association to the right device before running apt commands. Especially if you're on Linux.
Right.
Okay. And then once that's installed, I'll just run sudo minicom. And what do you see? Serial output.
Yay!
So it's just reading directly from that, and it's outputting it into this console.
Cool. And whatever you're debugging, you'll get the output here. So that's really nice.
Yep. It makes debugging much easier.
Mm-hmm.
Be aware that this only works when the ESP32 is like physically on the Pi. Right. Because it's reading it from the Pi.
Exactly. It's using the UARTRX and UARTTX pins on the Pi. Here, we can actually show you that it works without the Pi. Carlos here is motioning to us to show you that it does work without the Pi, since we are doing OTA stuff, so that you can believe us. Here. Cool. So the UART won't work anymore because we just took it off the Pi. But as you can see, the program is running and there is no Pi. No magic being done here.
And then you can actually just go ahead and you can do an OTA without it even on the Pi.
Right.
So I'll run an OTA right now.
Awesome.
And there it goes.
Yay! This is going faster than I can count. Hence, it's pretty fast. Cool. So yeah, it freezes when it's uploading, but then it'll start again and it's uploaded. Yeah,
whatever code's running on that pauses for a bit.
Mm-hmm. I guess it gives it an opening to upload code.
Yep.
Cool.
Yeah,
all right,
and there it goes. It's running again.
Nice. So proof that it is indeed standalone ESP32 voice friendly.
Yep. And then just one last thing. I didn't show you how to close Minicom in that other window.
Oh, true.
So in order to, I can't show you now because the Pi is unplugged. But to close it, you would press Control A and then X, and then it would ask you if you wanted to exit Minicom, to which you would click yes and press Enter. Well, you would navigate to yes.
Perfect.
Yeah. And then once that's done, you can use your serial for other things, and you can also actually communicate back and forth. So if you have the ESP32 connected to the Pi and you want to do a project that just communicates like without WebSockets, without any fancy servers, just want to go directly from Pi to ESP32 communication, you can do that with serial. So it's like standard Linux serial on the Pi side, and then on the ESP32 side, there are serial read functions built into, I think, like the Arduino toolchain. So
That's awesome.
you can do that.
Yeah, I think there is. Yeah, if you just look up Arduino serial read, you should be able to find it.
So
Awesome.
that concludes this guide.
Yeah.
Thank you for
watching.
listening to us. Yeah.
Okay, we'll switch back to here. But just outline that there are troubleshooting steps that you can go over before before you post on the community if you need issues, obviously. But check out the troubleshooting steps if you're having any issues.
Yeah. So as for
particularly
this
Windows.
step, if you go inside PlatformIO.ini and you go to the MVID, this is like the host name of the device. If this host name is longer than 8 characters, it may not work. So ensure it's like 8 or lower. And then if the target upload still doesn't run, you can also just run this command. This is basically what the target upload command does.
Okay.
But just without
more directly.
Yeah.
Yeah.
Without all the nice polish of
the command.
Yeah, this looks way neater.
It doesn't hide it, basically.
Yeah, this is what's actually running in the back end.
All right. Okay. So now that we have that, I mean, so that's it. That's crazy. That's so quick. I mean, we'll switch back to the front right here. Cool. So that was our guide on how to set up the ESP32 programming environment so you can edit, compile, upload super easily, just easily. I mean,
and debug.
And debug. Yes, that is very important. The first time I tried ESP32 stuff with LED debugging,
that's difficult.
Was a nightmare. It was a nightmare.
Yeah,
now
reading the serial port's important.
Yeah, now you can debug through serial. You can connect it to the Pi, debug through serial, or you can connect it to an FTDI module. You can get them from Adafruit, SparkFun, like if you want. But I mean, it makes sense to do it through the Pi if you already have it. All right, so we'll do quick announcements. Thank you, Boris, by the way. That was great. Quick announcements. Contest is going on. Hardware applications close August 25th. So there's like 11 days left. Get on that hardware. Free hardware is not easy to come by. And the contest in general will go on till I don't remember, but it is about 3 months long. So it's been 2 weeks-ish, so there's still 2.5 months. Build something super cool with snips and, Matrix Voice or Matrix Creator or some ARM thing along with, Anyway, cool stuff. All right, I'll close out here. Thank you for watching. Boris, do you have anything to say?
Yep, thank you for watching, and I hope you enjoy programming your ESP32 as much as I have. It's a really fun board to play with.
Yeah, we'll be releasing more guides too. Bye!